All right, let's talk about this section 2. This part 2 here. Now, this is really focusing on the end behavior, and so what I've highlighted in this little box or this little part here are these 4 types which you need to have memorized. And so you need to know up, up, which is an even positive, down, down, even negative, up, down, odd positive, and uh, down, up, excuse me, odd positive, and then up, down, odd negative. So all you're doing is giving in the information, looking at the equation, and then finishing the end behavior. So the other part is you do need to be able to write out the end behavior as an expression. So we have here the degree is related to your exponent. So the exponent is 2, so that's even. And the leading coefficient is 5, and it's positive. So now this is what you have to really be able to interpret. Because I know I have an even positive, excuse me, which is an up, up. As the x approaches a negative infinity, going from left to right, since that up, that would be a positive infinity. If the arrow is pointing up, it's positive, and if the arrow is pointing down, it's negative. So as x approaches infinity, it's still pointing up, so that's positive infinity. So I kind of was just going to focus on the odds here, so you can check your understanding. So I went ahead and showed 7, which is a degree of 3, because your exponent is 3, which just means it's an odd, and the coefficient was positive again. So that's a down, up. So as the x approaches the negative infinity, I look at this arrow right here, it's pointing down. So that means this is a negative infinity for the function. As it approaches a infinity to the right of the graph, the right side, the arrow is pointing up, so that's a positive infinity. So you go from, breaking it down to each part on this next section here. Yeah, then it's just giving you the equation, and then it just wants you to identify the end behavior. They just want you to complete the statement looking at the equation. So you just kind of have to put it all together. If you need to list your coefficient and your degree to help you see it, then you can. But really, you're focusing on this first part of every equation, here and here. And then from there, you can complete your end behavior. So do make sure you can at least complete this statement. That's definitely going to be asked of you. All right, and then in this section, now they're giving you the graph, and they want you to identify the function as odd or even, looking at your end behavior, and if the leading coefficient is positive or negative. So if I look here, because I have these 2 turn points, and because it looks like it's doing, oops, sorry, because we have a down, up, that would have to be an odd degree. And then because I have 2 turning points here, the degree is always 1 more, so this would be a degree of 3. And because it's up, down, down, up, excuse me, it's positive. Okay. And the way I determined it, I just looked at the turning point to check my degree, and then I looked at the end behavior. So if I look at this one, again, I have 2 turning points, 1, 2. The degree is 1 more than that, so it's a 3, which means we have, and I forgot to write it on this one over here, we have an odd, and this is also an odd. And then because it ends up, down, the leading coefficient is actually going to be negative. So my justification would just be looking at our turning points and end behavior. And I'll just abbreviate that. Okay, turning point and behavior. Now, if I look at this one, we have 1, 2, 3, 4 turning points, but the degree is always 1 more than that. So if it's 4, this would be a 5, which again means we have an odd. And then I look at starting up and ending down. If it's up, down, then that's a negative. Okay. I think you kind of have the hang of this. All right. All right, so that takes care of that section. The next section is dealing with the graphing calculator, so I'm going to do a different video for that. All right. Thanks, guys.